Hey guys, welcome to Code Templar. Today we'll be solving one very interesting problem. So let's start with the question. Find all possible recipes from given supplies. So let's go ahead. So you'll be given a recipe, what you have to make, and you'll be given ingredients. Basically, ingredients is a two-dimensional array, okay? And every index basically is an array, okay? And the elements in that array basically is used for making the recipe at that index basically in the recipe array, okay? And the third array is supplies, okay? Supply is basically you have infinite supply or infinite supplies of all those items which are there in the supplies list, okay? You have to return the output. You have to return the recipes which you can make from the given supplies, okay? So let's take an example. The recipe is bread. You have to recipe is bread. Basically, you have to make a bread, okay? What's the ingredients needed for making a bread? We need yeast and flour, okay? And what are the supplies given to you? So you have infinite supplies of yeast, flour, and corn. Will you be able to make bread? Yes. We need yeast and flour, which is already there in the supplies, okay? So yes, you can make bread. So the output you return over here is bread, okay? Let's go to example 2. You are given a recipe bread and sandwich. What are the ingredients? So yeast and flour is needed for making bread, and bread and meat is basically needed for making sandwich. And what are the supplies given to you? You have yeast, flour, and meat in ample amount. Will you be able to make bread and sandwich? So let's check. Since you have yeast and flour already, it is there in the supply, you'll be able to make bread, okay? Since you made bread and meat is being used for making sandwich, so from yeast and flour you can make bread, and once you made the bread and meat is already there, so you can make sandwich. So here you will be able to make bread and sandwich both, okay? Let's take example 3. You are given a recipe bread sandwich burger, okay? Ingredients given. Ingredients basically you need yeast and flour to make bread and meat for making sandwich, and you need sandwich, meat and bread for making burger. And what are the supplies given to you? You have yeast, flour and meat. Will you be able to make recipes? And if, then what all recipes you can make? So you have yeast and flour. Yes, you can make bread, okay? Since you can make bread and you already have meat, then you can make sandwich as well, okay? And you have sandwich. Since you made sandwich and you already have meat, and also you have made bread, then since all the three ingredients you have, you can make burger as well. So what will be the output? You can make bread and you can make sandwich and you can make burger as well, okay? So this is the problem statement. Now let's jump to the approach. Let's start, okay? See, I am just drawing. See, yeast and flour, okay? These two are needed for making bread, okay? I am drawing an arrow, okay? You are given meat, okay? You have bread and meat, okay? And what you can make? You can make sandwich out of this, okay? Now what you have? You have sandwich, meat and bread. So what you can make now? You can make burger, okay? So this is how it will be pointing. Can you think what we are doing? How we can proceed? This is basically a kind of graph, and if you have idea about the topological sorting, then you will get to know that this is an example of a topological sorting and how you are supposed to solve this problem. So basically, in topological sorting, what we do? We first pick those nodes which have in degree 0. We process it into the queue and we remove those elements from the queue, and the one which is attached to those nodes, we decrease the in degree, and then we push the new sets of nodes whose in degree became 0. And with this, we print the elements basically, uh, which we are able to print the element, basically elements in the sorted order, in the sorted topological order. But we don't have to sort here. What we have to do here is we will we like in topological sorting, we will do a topological sorting over here. But while processing each node, we will check, is that node present in this present in the recipes? Yes. Yes. Then we will print. Then we will basically print. We will add that into the output list. So let's start. What I did, I took a queue. Okay, sorry. I took this queue, and initially what I did, I push all those elements which have in degree 0. So basically, if you see east, floor and meet from the diagram, we can see east, floor and meet, it is having in degree 0. I push this element in the queue, floor, okay, and meet. The in degree is 0, 0. For bread, we have 2 in degree. For meat, we have 0. For sandwich, we have 2 in degree. And for burger, we have 3 in degree. Okay. I popped this element from the queue basically, and I decrease the in degree of the element connected with the east, basically connected with this particular node. So bread is connected, I will decrease the in degree of this node. Okay, since no other element is connected with east, I will move to next element. What is my next element? Floor is my next element. I checked the element which is connected with the floor, bread. Okay, so what I'm going to do here is I am decreasing the in degree. Okay, since the in degree became 0, I'll push it into bread. Okay, and is there any other element connected with the floor? No. So the iteration with floor is over. One more thing, while popping the element, you have to check whether these popped element, do it belongs to is it there in the recipe? Since in the recipes we don't have yeast, we don't have flour. Okay, so let's ignore this. Now we process meat. Which elements is connected to meat? Sandwich. I will decrease the in degree. Okay, is there any other element? Yes, burger is connected with meat, so I'll decrease the in degree. Okay, and now it's over. Then we'll move to next element, bread. Okay, bread and one more thing, is meat there in the recipe? No, it's not there in the recipe, so we'll move to bread. Okay, bread, which elements is connected with bread? Sandwich, so I'll decrease the in degree. Okay, yes, is there any other element? Yes, burger is connected with bread, so I'll decrease the in degree. Okay, and since after decreasing the in degree of sandwich, the in degree became 0, so I will push it into my queue. Okay. Now I'll check, is bread present in the recipe list? Yes, bread is present in the recipe list. So I will add it into the output list. Okay, bread. Now bread is over. Let's go to next element, which is sandwich. Sandwich. Okay. Which element is connected with the sandwich? Burger. And we will reduce the integrity. It will become 0. So burger. Okay. Is there any other element? No. So basically sandwich. Now I'll check whether sandwich is present in the recipe. Yes, it is present in the recipe. So I will add it into output list. Okay. Now we will check another element, burger. Is there any other element connected with burger? No. So we don't have to process any, we don't have to decrease the degree of any other element. Now we'll check, is it present in the recipe? Yes, it is present in the recipe. So we will add it into the output list. Now my queue becomes empty and I don't have any other element to process. So my output becomes this, bread, sandwich and burger I will be able to make. Okay. So this is an example of topological sorting and how you'll be solving this problem. You will create a map. Okay, you'll be creating not map, sorry, you'll be creating a graph where the in degree of the supplies basically will be 0. Okay, this is the supplies and the basically the in and the recipes will be having the in degree will be having in degree which is equal to size of the ingredient list. Okay, so if you'll see, ingredient list is for bread we need 2 elements. So 2 element will be pointing to this bread and my in degree will become 2 for bread. Okay, so this is how you'll be constructing a graph and you will be doing a topological sorting. You don't have to print the order. Basically, while doing the topological sorting, you have to check whether that recipe is present. Basically, while doing the topological sorting, whatever element you are getting, you have to check whether it is present in the recipe or not. If it is not present, then we don't, it doesn't matter. But if it's present, we have to put it in the output list. So this is the recipe which I'll be able to make. Let's say if you are given a question, you need to print the order, uh, how we are going to make the recipe in particular in basically ascending order. So this is how. First I'll make bread, then only I'll be able to make a sandwich and then only I'll be able to make burger. Okay. So this is my Leetcode solution. Um, let's let's go and check. So basically what I did is I am creating a map out of the ingredient and recipe list. Okay, similarly the way which I have shown in the diagram. Okay, and I am creating there is in degree map basically is storing the in degrees of every recipes. Okay, uh, recipes basically and what's the in degree is the size of the ingredient. So basically in this loop, you will see I'm populating the map and I am creating the in degree out of it. Okay, and what I did, I pushed, I have converted the recipe array and supplies array into recipe set and supply set. It is because searching will be easy for me. In array, I need to iterate, iterate in iterate basically, and need to find at which index we got that recipe. So basically, I have pushed the element into set, basically converted into set, and so searching will be easier and faster. And what I did, I pushed the supply set into the queue. because definitely the supplies I am having and the integrity of the elements in supply sets will be having 0. Okay, so I don't have to iterate in the map and need to find the integrity. Okay, so supply set will be having the 0 integrity. Now I am popping the supply set. Okay, after popping the supply set, if that supply set is present in the graph, I mean, is there any node starting with supply set element? If it is, then we are finding the nodes connected with it and we are decreasing the integrity. If at any point of time integrity becomes 0, I'm adding it to the queue. If recipe set, basically recipes is do the element connected with the recipe set, are we having that in the recipe set? If it is having, then I am adding it into the output list and I'm returning the output. So this is a simple solution. Okay, and if you face any difficulty, do comment and please like this video. If you need, if you want me to come solve any particular problem, do comment in the chat and I'll make a video out of it. Thank you so much.